YouTube. Fine. So this is our course objective, or with this course objective, you can divide the computer into software, components, application in society, and categories of computers, network, and internet using computers. So there are varieties of categories available, and based on this you can write a lot of things about computer, like there are two types of software: system software and application software. All these things are elaborated in detail in the next slides. So this is the unit 1 content: introduction to computer history, one human architecture, memory, system hierarchy, hardware component, data representation, character representation, binary octal, binary arithmetic, floating point representation. Whatever written in red color, it is very important. And I think you have idea about those who have done the course. They know very well that the instructor there also told that without number system, you won't be able to do anything. Okay. And number system is very, very important. In Duke University course, the instructor said that each and everything can be represented as a number. And in Colorado also, he has explained the same thing about the um number system. So whatever, yes, it is correct that whatever things are written, it is in binary. Like whatever information you want to print or you want to see the image. Okay, suppose I am designing one image, so you just tell me what is written here. What is written here? I had marked cross. Anyone? Am I audible or not?
Yes, sir, you're
Yes,
audible,
sir.
sir.
So what
It's a
is written
five and
here?
So 5.
5
Five.
S, 5 S. Any other thing?
two.
2 is
No,
not
not two,
written.
not two, not two, not two, not two.
Yes. So 5 and S you can say. So if I am putting bulb over all the places, okay, this is a matrix, whole matrix, okay. And if we glow the bulbs of these places, okay, so this will automatically looks like uh, 5 or S, whatever you want. So the same concept we have used in binary representation. Okay. So based on binary representation, only on and off is given. So based on this on and off, we can construct so many bits of number. So I will tell you in number system, but before that, we need to see what are the computer components and categories. So this is categorized into software components, application in society, already shown you. Here, let us see about input and output devices and computer components. So computer components can be divided into input device, output device, system unit, storage device, and communication devices. So all these things I had explained, okay, what is given and what is not given. So this is in my YouTube video. So just see about this. These are the processors, input devices. You know very well that barcode reader, optical pen, and these are the in means devices between input and output. Okay, so many things are there, and here I had given comparison between SSD and HDD. So not only whatever given in syllabus, but it is also mapped with the current technology, that how do we categorize the hard disk, different type of storage devices into different categories. So here SSD is shown and HDD is shown, and this time the same time because students are interested to purchase their laptop, so I had explained that if 512 GB space laptop is available with SSD, then you can purchase that. Fine. Because processor in conjunction with SSD high speed devices will perform very good. Okay. And these are the processors. Nowadays, no processors are available except Core i3, Core i5, and Core i7. All other processors are outdated. Okay, obsolete kind of thing. But I need to explain examples. Other than these processors, Qualcomm, Exynos, Kirin, MediaTek and Ryzen processors are also available. And beside this, graphical processors, GPUs are also available. So you can use graphical processing unit also. But it is not mandatory. If you are going for parallel programming sort of thing, then only you need to purchase graphical based system. So these are the categories of computer: personal computer, mobile computer and mobile devices, game console, servers, mainframe, supercomputer, and embedded computer. So very old computers are mainframe computer. These are the computers where inside that we are working. Okay. So we will see the picture of mainframe computers also. Then server like Gmail, whatever facilities we are using, or Microsoft Office suite, PowerPoint, MS Team, these all are based on server. The actual software is there in servers, and we are using facilities of these softwares as an API, okay, or application. Gaming consoles are available: PS2, Xbox. This has also very big market. Mainframe, so I had explained supercomputers, the power of n number of computers, like thousands of computers are connected together to produce a dedicated result. Embedded computers like washing machine or your watch or television set, fans, smart fans, all the smart appliances embedded with some sort of computing power, and they are having their processors inside that. Then come to mobile sort of computers, so notebook computer, tablet PC, smartphones, uh, PDA, personal digital assistant, like uh, GPS device, whatever there in car, handheld computer, portable media player like iPod, Mini, etc., and digital camera. These are the special kind of mobile computer. And then come to personal computer. So the computer which is used for which is used inside the computer. So I think a lot of persons have not means they are not having their personal computers, but they can see in supermarket there are computers available. Okay, so this is also known as desktop computer. So desktop PC computer, because um, due to portability of laptop, the persons are not purchasing personal computers nowadays. Then come to software. So there are three categories of software, or two categories of software. Mainly two categories of software: system software and application software. System software is a software which is written for system related activities, and this is further divided into operating system and utility program. So what is operating system? Like Windows 10 is one operating system, uh, Apple is another operating system, Android is another operating system, Linux. So many flavors are shown here. These all are representing a particular operating system. So the BSD kind of operating system, BSD, OpenBSD, NetBSD, Dragonfly BSD, and Darwin, all these categories belongs to Unix based operating system. Actually, these are the free source code of Unix based operating system, and Unix is proprietary software. It means Unix, you need to purchase Unix. Okay. So what is the full form of BSD? BSD is Berkeley Software Distribution. So it was developed in University of California, Berkeley. Okay. So in Berkeley, they have developed one group, like one we are having incubation center sort of thing. So they are having their free BSD, means Berkeley Software Distribution lab. There they have developed Unix operating system, and based on this Unix, it is freely available to all of you in terms of free BSD, OpenBSD, NetBSD, Dragonfly, and Darwin. Then this, because the source codes are available based on this codes, in 1991 Linux has developed, and this Linux is free of cost available. But nowadays there are two flavors of Linux available, like Red Hat and Fedora. Those are the counterpart. But Fedora is open source. Open source, all the Linux based systems are open source, but Red Hat is a proprietary operating system, and Fedora is not a proprietary operating system. It is available for means you can use it freely. Then come to CentOS and Debian and Ubuntu. A lot of flavors are there. Open source does not mean that it is freely available. Open source means source code is available, you can use that source code. Okay, while closed source is also not means that it is available with a cost. Some softwares like Notepad++ and some other softwares are available freely. So both the things are there. Okay, so these are kind of license. And then Sun has developed Stanford University network. Okay, Sun means Stanford University network. They have developed so many things like Java. They have developed one operating system, very beautiful operating system. Solaris was developed by Sun Microsystem. But later on, due to its availability to common people, it was failed, and that's why it is not available to all other. Then VMware having its own operating system. Apple is very glamorous operating system. Everybody wants to purchase Apple because of status symbol and some other thing. And but one feature I definitely agree with Apple is that the high degree of security. Okay, so high degree of securities are there with the Apple operating system. So these are the operating system special kind of programs. Now come to utility programs. So utility programs are antivirus. Okay, then VirtualBox is another utility software where you want to install one operating system, one more operating system. In earlier days, what happened? We need to install both the operating system, and we need to flip at least means any one operating system, either of operating system. So we need to flip, then flop, then flip, then flop. We cannot enjoy both the operating systems simultaneously because of single PC. So due to this, they have developed one solution, and this solution is known as virtual machine. So after virtual machine, so many virtual machines are available, and if you people are using any virtual machine, it is my personal suggestion that better to use VMware instead of that Oracle's VirtualBox, because it fails several times. If you are using Apple operating system, Apple Mac, then you can use Parallels. Okay, so in that Parallel, you can install Windows operating system. In Windows, you can use not VirtualBox, VMware. So VMware Personal Edition is also available. Means it is not personal, it is yes, utility edition. So these are the utility software. Another utility software is antivirus. So antivirus program is also very important, and so many utility program which is not directly related to us, but they are providing care for our system are known as utility program. And now come to system software also includes special program. And these special programs are compilers. Okay, compilers or language translators are also example of system software, which will give you a big flexibility. Like here, system software is classified into two domains: operating system and language translator. So operating system like Microsoft, Unix, and Windows, Mac, Linux, etc. And compilers are the intermediator between system and user. So user can write the code in high level language, and compiler can translate it into low level language. So there are a lot of language compilers available like C, C++, Java, and some other. Fine. Then assemblers means whatever computer you are using, whatever mobile phone you are using, they are having their different processors. So processor is based on different set of mnemonics, okay, or their code, assembly code. So based on this assembly code, you can run your program. So what compiler does, it translate the higher level language into assembly code, and then assembly code is translated into machine level language. Okay, so assembly is little bit understandable by user. It is a middle level kind of thing. Okay, and low level is whatever written in zeros and ones. Interpreter like Python, you need to type one programming line and then press enter. It will automatically compile that. So line by line compilation is known as interpreter. Basic, this was very old language, BASIC. So that language also uses the interpreter. Then come to another domain, application domain. So application means there are two schools, general purpose and customized software. General purpose means Word, PowerPoint, Excel. These all are general purpose software. Whenever a person is using 2019 Word 2019 in their system, in my system, everywhere the same thing will be there. Only the license holders are different. So this is known as general purpose. But billing software is different for all the billers, all the medical stores, all the other means all the supermarkets. So everywhere their own proprietary software has been developed by some third party or software developer, and this is known as application software and means special purpose application software. So here are some example: MS Word, PowerPoint, billing system. These are the example of software. So be aware of all these kind of software system. Okay. Then come to network and internet. Okay, there are lots of things available with network. First thing is hardware-based network. So what are the hardwares available for networking? There are different hardwares nowadays we are using. If I think you are having ideas about all these hardwares. So let me show you some of them. Like modem is the basic kind of thing. Modem is modulator and demodulator. So how modems we can use, and then hubs are also there, and like whatever we are using, modems are always connected with computer, and this modem is available, and then we can use different routers. Okay, routers are available. So nowadays what happened, there are two different kind of system. Either both the things are combined or separate. Like in case of optical service provider, they provide optical modem first thing, and second thing is router. Okay, so from incoming means optical is coming from service provider to modem, and then from modem to this router, it is available in form of digital signal. So now this digital signal is available for all. Then there are routers, gateway. You don't know about gateways, okay? And bridges, switches. These are a special kind of hardwares which we use. Even repeaters. If you are having very big house and you want to share your network, then you need to put repeaters at certain place. They repeat the signal. Okay. So most common kind of repeaters are mesh. If you are going to purchase, if you are having Geo fiber and your big home is there, then you need to provide one repeater also. And this repeater repeats the signal of your Geo fiber to all the house, entire house. Now come to application, internet. Internet includes communication like WhatsApp call or bottom call, or different calls are there. Research and access information. You can access any website. You can research like what is the current rate of mortality with respect to COVID-19. Then you can shop online, Amazon. So many websites are there. Some of them are all means closed nowadays. Snapdeal is not available, I think, or may be available with some other. So online shopping, trading, bank and investment, entertainment, music download, share video, web application, Facebook, Instagram. These all are application of internet. Now come to application in society. So education, whatever we are using, finance, government, healthcare, science, publishing, travel, manufacturing, these all are example of application in society. Now come to using computer. What are the advantages? Speed is a tremendous advantage. Reliability, consistency, storage, and communication. Computer is whatever computer you are using, it is emotionless device. Okay, they are not able to do by their own. It is based on instructions provided by us. Reliable means if 99 plus 99 is 198, every time it is coming 198. But the person who is very literate, PhD sort of person with a degree in classical dance, and if you ask the question, what is 99 plus 99? I don't think means the answer is always same. Okay, depending on his capability, his speed. Okay, maybe he need to add all these things and uh, put the result. So some person may say, may give you answer as 188. Okay. Some give you as 198. There are two different kind of persons available, but computer always give you the same answer. So this is a reliability and consistency kind of thing. Then storage, tremendous storage is available. Communication capability is also, because it is mechanized communication system. So always do in mechanical fashion. Then disadvantage is whenever we are using computer means for a long time, then health risks are also there. Violation of privacy. So you must know that nothing is private in this digital world. Even your passwords, even your photographs. Once this is coming to internet, it will be available anywhere. So be careful while you are when you are recording anything. Okay, don't record anything obscene or objectionable. Fine. Then public safety is it was a traditional issue. Nowadays, it is not a big problem. Fine. Then impact on labor force. It is assumed that due to computer, a lot of labor force is unemployed, but I don't think so. Okay. And impact on environment. This is definite thing. Whatever, even I am pointing this much, it is consuming electricity or electron, and whatever communication between you and me is there, it is based on communication of electrons per second. And whenever electrons are running from one place to another place, it will consume electricity. And this electricity is the result of either hydropower plant or thermal power plant or nuclear power plant or solar power plant. So all these things involve material, because the equation E equals to mc square. Okay, so mass must be there, and due to this mass, the pollution or impact on environment is also there. Now come to interesting part of computer history. First computer was the ABACUS, known computer was the ABACUS, and there are franchises available in your city also. The ABACUS, a simple counting machine, and may have been invented in Babylonia, now in Iraq, in the 4th century before Christ. This device allows the user to make computations using a system of sliding beats. There are beats in upper half and lower half. So based on sliding of this beats, you can uh, calculate the things. Yes, any doubt? And it was considered as the first computer. Blaise Pascal has invented one machine known as Pascaline. So this is the device available, Pascaline. Okay. So it was invented in 1642. Fine. So each and every devices they are showing different years.
एक वहाँ लगाना है अपन को एक यहाँ लगाना है एक बार कोड बढ़ाना ताकि दोस्त सब तक गए गूगल पे फोन पे डाउनलोड कीजिए
क्या बात है दक्ष?
बोले थे फोन
Okay. So this is Pascaline. Then come to Gottfried Wilhelm von Leibniz. Okay, so Leibniz theorem you have learned in mathematics. So it was he has invented one machine, and that is known as stepped Rockner. Okay, so supposed to be able to add, subtract, multiply, divide, and calculate square roots. These are the facilities. And with the previous Pascaline machine, it was only addition of numbers. Here, a lot of things available. Fine. Then Charles Babbage has invented his special machine, and that is known as Babbage's engine at Computer Museum. So you can see that this is the machine. Okay. And Charles Babbage was considered as father of computer, and he was born in 1791. Fine. So there are two different machines shown here. One is a difference engine. So whatever shown here is actual difference engine. And in left hand side analytical engine, it was developed in 1833, but and it is used to perform a variety of calculations by following a set of instructions or program stored on punch card. But this machine is only available and no other things are available. So here the white portion is shown as punch card. It is punch card, and based on this, it will perform automatic computation. After that, Jacquard has invented special punch card. Okay, and these punch cards are used for looms. Fine. So in textile they have used, and it was very old. Means on the basis of this punch card, they are able to uh, print different patterns of textile machines. So the same punch card were used in our computers. Okay. So this was invented by Joseph Jacquard for looms. Then Ada Baron Countess of Lovelace. She was first women programmer. Okay. And actually she was first programmer, not woman, first programmer. And
pioneers of early computers. As a young girl, she was fascinated with maths and science, and at 17 years old, she met a man called Charles Babbage, who had designed a cogwheel calculating machine. Ada was amazed by the model that he had made, and they soon became good friends. In 1834, Charles Babbage began work on another, more elaborate computer called the analytical engine, and it had been thought that Ada only had a small part to play in the design. However,
so you can see it from my YouTube video. Okay. Then tabulating machine was developed for US census. It took 10 years to complete all these things. Okay. So, but after that, Herman Hollerith has devised one machine that is Herman's based on punch card, and it is able to calculate the population. So this shows the population clock. Okay. And based on this, this is the machine.
1960, 1911 Powers as the leading company in supplying machines for the shipping market. It became the major supplier to the government, and the electronic control circuits provided flexibility in programming, such as in the highly successful IBM 604 electronic calculating punch, introduced in 1948. In 1953, IBM announced the 650 magnetic drum data processing machine, one of its early computers.
So this was developed by IBM, and then another this machine was very popular, and this is also based on the punch card. So you can see that this I had experience of these punch cards, but not machine. I saw the punch card for one industry. Okay, and it is very similar to that punch card. Then Howard Aiken during in 1944 he had developed Mark I computer, and it is running computer, and here it shows the dimension of this. Fine. So This is the machine, 51 feet long and 8 feet tall machine. And it is running. And this Howard machine is available at Harvard University. Fine. So then come to ABC computer. ABC computer was developed by Etnasoft and Clifford Berry. So that's why its name is ABC. Okay. There are punch cards available, and based on this punch card, it is able to calculate different things. So many logics are there. Then ENIAC was come into existence in 1946, and here you can see that so many devices are connected, and these devices we need to refresh. Okay, and the hall required for this is 1500 square feet, average area of 3-bedroom house. So this is the ENIAC 1940 ENIAC computer.
Personal talks with the engineers, direct designers Jay Preston.
Let me show the last thing, where you can see the pattern of
a portion of the ENIAC still resides at the University of Pennsylvania.
A particular
Other components of ENIAC reside at the Smithsonian Institution in Washington, D.C., the Computer History Museum in Mountain View, California, and other locations. ENIAC remains a milestone in computer development.
And the remarkable thing was vacuum tube. This is a special kind of thing which only travels in one direction. Okay, means if you want to do something, so only one dimensional means one directional, unidirectional communication was available, and that's why the transistor was used. Okay, vacuum tubes was used, and then after that it was converted into transistors. The only disadvantage is that we need to change the vacuum tubes after every 20 or 30 seconds. So this also means heat dissipation is very high, and power consumption is also very high. It requires very high power as a small power station. Then in 1930s and 1940s, you will read one subject in future. The name of subject is Formal Language and Automata Theory. Okay, so the person Alan Turing developed the universal machine, and this universal machine is capable of doing anything. Okay, based on just we need to change the instruction, it will automatically perform certain different things. So he envisioned a computer that could perform any different task by simply changing a program rather than by changing the electronic circuit. In previous system up to that time, we need to change the vacuum tubes. And once we have developed a computer for a square root calculation, we cannot modify it. We need, if we want to modify, then we need to change the circuitry and we need to change the logic. But here, only based on computation, we can calculate if multiplication, division, etc. are available, and inverse is available, then you can calculate anything. Okay, anything. Then John von Neumann developed a machine which consists of input-output, including central processing unit. This part includes central unit, control unit, and arithmetic and logical unit, and also the memory. So here we have started the stored program organization concept. Stored program organization. So this was changed the computer thinking on computer, that how to design a computer. Now memory unit is also available. So based on memory, different computers are available. Then come to transistor. Transistor was developed, and this transistor.
Modern computers are revolutionizing our lives, performing tasks unimaginable only decades ago. This was made possible by a long series of innovations, but there's one foundational invention that almost everything else relies upon: the transistor. So what is that? And how does such a device enable all the amazing things computers can do? Well, at their core, all computers are just what the name implies, machines that perform mathematical operations. The earliest computers were manual counting devices, like the abacus, while later ones used mechanical parts. What made them computers was having a way to represent numbers and a system for manipulating them. Electronic computers work the same way, but instead of physical arrangements, the numbers are represented by electric voltages. Most such computers use a type of math called Boolean logic that has only two possible values, the logical conditions true and false, denoted by binary digits 1 and 0. They are represented by high and low voltages. Equations are implemented via logic gate circuits that produce an output of 1 or 0 based on whether the inputs satisfy a certain logical statement. These circuits perform three fundamental logical operations: conjunction, disjunction, and negation. The way conjunction works is an AND gate provides a high voltage output only if it receives two high voltage inputs, and the other gates work by similar principles. Circuits can be combined to perform complex operations like addition and subtraction, and computer programs consist of instructions for electronically performing these operations. This kind of system needs a reliable and accurate method for controlling electric current. Early electronic computers like the ENIAC used a device called the vacuum tube. Its early form, the diode, consisted of two electrodes in an evacuated glass container. Applying a voltage to the cathode makes it heat up and release electrons. If the anode is at a slightly higher positive potential, the electrons are attracted to it, completing the circuit. This unidirectional current flow could be controlled by varying the voltage to the cathode, which makes it release more or less electrons. The next stage was the triode, which uses a third electrode called the grid. This is a wire screen between the cathode and anode through which electrons could pass. Varying its voltage makes it either repel or attract the electrons emitted by the cathode, thus enabling fast current switching. The ability to amplify signals also made the triode crucial for radio and long-distance communication. But despite these advancements, vacuum tubes were unreliable and bulky. With 18,000 triodes, ENIAC was nearly the size of a tennis court and weighed 30 tons. Tubes failed every other day, and in 1 hour, it consumed the amount of electricity used by 15 homes in a day. The solution was the transistor. Instead of electrodes, it uses a semiconductor like silicon, treated with different elements to create an electron-emitting N-type and an electron-absorbing P-type. These are arranged in 3 alternating layers, with a terminal at each: the emitter, the base, and the collector. In this typical NPN transistor, due to certain phenomena at the PN interface, a special region called a PN junction forms between the emitter and base. It only conducts electricity when a voltage exceeding a certain threshold is applied. Otherwise, it remains switched off. In this way, small variations in the input voltage can be used to quickly switch between high and low output currents. The advantage of the transistor lies in its efficiency and compactness. Because they don't require heating, they're more durable and use less power. ENIAC's functionality can now be surpassed by a single fingernail-sized microchip containing billions of transistors. At trillions of calculations per second, today's computers may seem like they're performing miracles. But underneath it all, each individual operation is still as simple as the flick of a switch.
So this is transistors, and vacuum tubes are like this, and these are the transistors, and this is transistor radio based on all the transistor devices. After that, first computer bug was found by Grasshopper. Actually, we need to write the program in this sheet, and that time one bug was there, and due to this programming line, okay, we need to write program for particular line, and because it has shifted, so when we shift like in Python, you have seen that if we are not properly, what we can say, it is indent. Okay, so due to this indentation, the lot of errors were was there. So if we remove the indent, then automatically it removes the error, and maybe thousands or hundreds of errors are coming. So this was computer bug, physical bug available with computer program. Now come to Altair computer. Altair was the first personal computer, okay, but it was not available with it was not available with monitor, PC. So this Altair is like a CPU, and there are multiple switches available, but it is not available with the keyboard, video display, and storage device. So it was targeted as a first personal computer, and but the company was not able to fulfill the demand. Okay, and that's why some other computers were developed. Okay, and its cost is also very less for that time. It is in dollar 395. After that, uh, IBM PC was coming into existence. Okay, and then Macintosh was available for general people in 1984. Before that, Mac was originally Lisa, and after that, Lisa has transformed into Macintosh. It was very handy device. Okay, very handy means it is very small, and the CPU and all other
Amount
things
of
are
built-in RAM, which you can probably guess is
coming
512
into one single
kilobytes.
package.
This computer in the 80s was pretty expensive for a lot of people at a price of $2,795 US, which is equivalent to $6,443 today. This was sort of the standard price for a PC back in the 80s, if not a bit cheaper, but the 512K actually had a trick up its sleeve compared to other PCs. It had a graphical user interface. Now, Apple didn't actually totally invent the whole graphical user interface for desktop computers, but made it incredibly popular and more approachable. The first main computer, today we're familiar with multiple mobile carrier tell us for help me find these products to
After
make.
that,
Hi everyone, can you
Windows was coming into existence in 1985. Okay, monitor is separated. Monitor and all other parts are assembled separated. Okay, so this was so. So with this, we have completed the first part of introduction. If you have any doubt, you can ask. Now your task is to classify computer into generation. Okay, it is already given. So let me write the task for you. Classify the computers into generation. Okay, so there are 6 generations. In some book 5 as quoted, and in some book 6 as quoted. So just write down the components, the speed, the materials, the degree of integration, all these things you need to plot in one table. Fine. Now let us come to discuss the number system. These are the number systems. I will take 5 more minutes. These are the number system. We know only base 10. Okay, base 10 is nothing but it is decimal number system which are having 10 different numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's why it is known as decimal number system. If we are having only 2 number, then it is known as binary. If we are having only 8 number, then it is known as octal, and if we are having 16, then it is known as hexadecimal number system. Okay, you can make your own number system. So it depends whether you want to create any number system by base 3. So it includes 0, 1 and 2 only. So it means if I am writing any number 1, 2, 3, 4, 5. So this is not coming under this system. Fine. This may be available with base 6 and above. But until and unless it is not quoted there, then it is always considered as base 10 number. Fine. So don't get confused with this. So there are 4 different number systems. What is the objective of number system? Understand the concept of number system, distinguish between positional and non-positional number system. It is not our major objective. Describe the decimal, binary, hexadecimal and octal system. Convert a number in binary, octal or hexadecimal to a number in the decimal. Convert or vice versa. Convert a number in binary to octal and vice versa. Or convert a number in binary to hexadecimal. So let me show you another special kind of thing. So this is our conversion diagram. Okay, how do we convert from one number system to another? This. So here you can convert using this diagram from any number system to any number system. Maybe hexadecimal or maybe any base. Okay, if you have any number system, then also it is very easy. Like in lower portion, it shows mod k conversion. Okay, so I will explain you all these things tomorrow. So it is my expectation from all of you that please come with your preparation. Okay, just try to read it in internet, and tomorrow we will discuss a lot of things, and we will tomorrow majorly we will discuss 1s and 2s complement system. Fine, with 2 or 3 addition. Any doubt you can ask. No doubt. So let me close today's lecture and just try to see it in YouTube. So you will be able to find the first part of my lecture, and second part, this number system is very important. Tomorrow I will explain. Okay, I will just try to gear you up about number system, and then you need to try by your own, because it is very, very, very important. And I think you can ask all the persons who have done programming courses. They will also suggest you to complete this number system as soon as possible. So with this, I close today's lecture. Okay, so thank you very much. Have a nice day. Have a nice time.